Hello everybody, this is the notes for section 10.5. What we're talking about is some angle relationships with the circles. So we're going to be drawing chords, we're going to be dealing with secants, tangents, and the angles that are formed when secants, chords, tangents intersect and where they intersect. And again, as always, in the relationship of the circle. So if you have two chords, secants or tangents, they can intersect at a point. Now there are three places where they could intersect at. Whether they intersect on the circle, as shown here on the left, they could be intersecting inside the circle in the middle picture here, or on the picture on the right, where these segments or lines, if they're a secant, are intersecting outside of the circle. And so this location of that point, that changes the relationship between the angle formed and the arcs of the circle. So let's talk about it. All right. In section 4, we talked about this idea of inscribed angles and how the vertex is on the circle. So really, it's the intersection of two chords. It's the intersection that's on the circle. The inscribed angle was half the intercepted arc. So in this picture, this is for theorem 10.11, 10.11, what we have is a tangent line and a chord. Okay, they are intersecting at point A, which is on the circle. So, as it shows here beneath the picture, this measurement of angle 1, okay, that's the angle between the chord and the tangent. Its intercepted arc is arc AB, and so angle 1 is half of that intercepted arc. Same thing on the other side, angle 2. It's still an angle formed by the intersection of the chord and the tangent, but now its intercepted arc is BCA, arc BCA. But because the vertex of the angle is on the circle, the angle is going to be half the intercepted arc. All right, that's the key thing. Vertex of angle on the circle, the angle is half the intercepted arc. Now, if the angle is inside of the circle, a different relationship. So what we're talking about now is chords. Okay, so two chords intersect, not at the center of the circle. So looking at this picture, the center of the circle would be, like this point right there. Okay, neither chord is a diameter. There's no radii involved. It's just two chords intersecting. The angle formed is half the sum of the intercepted arcs. So you really got to pay attention to these statements. Angle 1, all right, that angle is intercepting arc BC, this arc here. Now, angle 1, it's got a vertical angle over here. That angle's intercepted arc is arc AB. So, angle 1, it's going to be half the sum of those two arcs. And that's what this statement says. Angle 2, the same thing happens. But angle 2, its intercepted arc is BC, this one here. And angle 2 is vertical angle, its intercepted arc. So, angle 2 is half the sum of those two arcs. That's when the angle is on the inside of the circle. You're taking half the sum of the intercepted arcs. All right, the last relationship is when the angles are outside of the circle. So, with the outside the circle, you got a couple different ways, and you got three pictures here. Really, it's just different lines forming them. In the first one, we got a tangent and a secant. In the middle picture, it's two tangents. In the last picture, it's two secants. But the vertex that we're talking about is this point here, and this point here. The vertex of the angle is outside of that circle. And so, the key thing here is the measure of the angle formed is half the difference of the measures of the intercepted arcs. So, when we extend angle 1 out, with this ray and with this ray. It's intercepting two arcs. It's intercepting arc BC and it's intercepting arc AC. Because the vertex of the angle is outside the circle, the angle measurement is going to be half the difference, okay, subtraction, half the difference of the intercepted arcs. And you're always going to take the larger arc minus the smaller arc, okay? In this middle picture, we have two tangents. Now, we know that tangents are equal length, but that's not what we're talking about. We're talking about an angle measurement in relation to arcs. But again, the vertex is outside the circle. So when you follow this angle out, it is intercepting two arcs. You've got the red arc, PQR, and you've got the blue arc, the minor arc, PR. The vertex is outside the circle. The angle is half the difference between the intercepted arcs. The same thing on this last picture here on the right. We had two secants. Intercepted arcs are XY and WZ. This angle 3 is half the difference between the intercepted arcs. All right, that is the notes. The next video contains some examples dealing with these. Bye.